Today we are going to discuss the Unit 1 Crystallography in the subject code PH3254 Physics for Electronics Engineering. Before discussing about the crystallography unit, so what is the need to study crystallography? Many materials having different properties, like some of material having magnetic properties, some are having electrical properties, some are insulator. This is because due to the arrangement of atoms. So understanding certain properties requires knowledge of atomic arrangement. In this crystallography unit, some of the terms we have to familiarize. First one is the lattice. So lattice point means the point which represents the atom's position, that is known as the lattice point. So this is the imaginary point which represents the atom's position. This lattice point, a periodical arrangement in 3 dimensions gives the lattice. So in this lattice point, it doesn't give the information about how many atoms in that particular lattice point at atom size. That will be given by this basis term. So group of atom in that particular lattice point, that is given by the basis. So crystal structure is nothing but the combination of lattice plus basis. So lattice is combined with the basis, we are getting the crystal structure. So crystal structure is obtained by arranging the bases in each and every lattice point. Then next is the unit cell. So in this crystal structure, smallest geometric figure which is repeated in 3 dimensions, it gives the complete crystal structure, is known as the unit cell. So crystal parameters, it is the combination of intercepts and interfacial angles. So in intercepts along the XYZ axis, nearest atom distance is known as the intercepts. If you are taking x-axis means the intercept value is A, and y-axis it is denoted by B, and in z-axis it is denoted by C. These 3 axes are mutually perpendicular to each other, so angle will be formed. The angle formed between the x and y is known as the gamma, and y and z is alpha, and z and x is beta. So alpha, beta, gamma is interfacial angle. A, B, C are intercepts. So intercepts and interfacial angles are the crystal parameters of the unit cell. So depending upon the intercepts and interfacial angles, we are having 7 type of crystal system: cubic, orthorhombic, monoclinic, triclinic, hexagonal, rhombohedral, and tetragonal. So the conditions of these 7 crystal system is tabulated here. So for the cubic system, the intercept values are A, it is equal to B, it is equal to C. Interfacial angles are equal to 90 degree. In tetragonal, A it is equal to B but is not equal to C, and interfacial angles are equal to 90 degree. In orthorhombic, A it is not equal to B, it is not equal to C, but angles are equal to 90 degree. In hexagonal, the condition for intercept value is A it is equal to B but is not equal to C. Here in interfacial angle, 2 angles are equal to 90 degree and 1 angle equals 120 degree. In rhombohedral or trigonal, A it is equal to B, it is equal to C, but angles, all the angles are equal and none will be equal to 90 degree. In monoclinic, intercept conditions are all the intercepts are not equal to each other. 2 angles in interfacial angle are equal to 90 degree and 1 angle is not equal to 90 degree. For triclinic, all the intercepts are not equal to each other and all angles are different and none will be equal to 90 degree. Then next is Previs lattice. So what is Previs lattice means? In this 7 crystal system, there may be a possibility of 14 ways of arrangement of atoms, that is known as the Previs lattice. If you are taking cubic structure, there may be a 3 possibility of arrangement of atom: simple cubic, face centered, and body centered. In simple cubic structure, all the corners will be occupied by the atoms. So 8 corners it has. So 8 corner will be occupied by the atoms. In face-centered cubic structure, 8 corner atoms are occupied and 6 face-centered atoms are also available. And in body center, with the 8 corner atoms, one atom will be at the center. Then in tetragonal, there may be a possibility of 2 ways of arrangement of atoms. Simple tetragonal means 8 corners will be occupied by the atoms, and body centered tetragonal means with 8 corner atoms, one body centered atom is also possible. And hexagonal, simple hexagonal alone possible. In simple hexagonal, 3 layers also having it has, that is top layer, bottom layer and middle layer. All the layers are occupied by the atoms. And in orthorhombic, 4 ways of arrangement of atom is possible: simple, body centered, base centered, base centered. In simple orthorhombic, all the corners, 8 corners are occupied by the atoms. In body centered, with the 8 corner atom, one center atom is possible. And in base centered orthorhombic system, 8 corner atoms, 2 base centered, top and bottom base, the atom will be occupied. In face centered orthorhombic, with the 8 corner atoms, 6 face centered atoms also possible. In rhombohedral, simple rhombohedral, so all the corners will be occupied by the atoms. In monoclinic, 2 ways of arrangement of atom is possible: simple monoclinic and base centered monoclinics.